Most leaders use AI-native and AI-augmented as they mean the same thing, but they are opposites. One delivers single-digit efficiency gains and a Copilot invoice. The other one rebuilds the way software gets made. 12 principles separate them. 12 fault lines. The arithmetic of where gains come from, where the intellectual property lives, who orchestrates and who implements, how quality gets validated, how costs scale, the binary nature of the commitment, and this episode walks all 12. A short setup before the walkthrough. The book is the AI-Native Software Development Lifecycle and was published in December 2025. The thesis is that traditional software development is a discipline, and this discipline is ending. The work of building software is moving from human hands typing in editors to human minds directing specialized agents. The organizations who move first own the next decade. The 12 principles in this episode are the operating contrasts between the two paradigms. No phases, not techniques, just fault lines. Each one names a place where AI-augmented thinking and AI-native thinking diverge, and where the divergence determines what your organization delivers. One number to keep in mind across the next 9 minutes: Copilot makes coding 30% faster. Coding is roughly about 20% of delivery work. The ceiling on AI-augmented at the system level is 6%. Anything above that comes from rebuilding the other 80% of the life cycle, not from making the 20% faster. That arithmetic shows up in every fault line below. Fault line 1. Whole life cycle rebuild, not phase substitution. AI-augmented bolts AI onto coding, sometimes onto testing. The other phases stay human-shaped with the same handoffs, the same artifacts, and the same governance overhead. AI-native rebuilds all 6 phases of software development lifecycle. Discovery becomes context engineering. Design becomes prompt architecture. Development becomes AI-orchestrated generation. Quality becomes intent validation. Deployment becomes autonomous operations. Evolution becomes continuous learning. And the substitution caps the gain at the 6% ceiling. Rebuild removes that ceiling. For line 2, the operating model defines maturity. Tools do not. 2 organizations with identical tool stacks produce different outcomes. The augmented one writes more code faster and ships the same features. The native one writes far less code and ships dramatically more capability. The differentiator is how context prompts, agents, and humans interact, not which vendors are on the invoice. Buying Copilot licenses is procurement. AI-native is an operating model. Confusing these two is how most enterprise transformations fail. Fault line 3. Process serves AI capabilities, not human limitations. Sequential phases, code reviews, integration cycles, release windows, change boards. Each one exists because humans struggle to work in parallel, hold full system context, or regenerate work cheaply. Each one is throughput accommodation for constraint AI agents do not share. AI agents work in parallel. They can regenerate instantly. AI-native processes assume what agents do well. AI-augmented processes preserve sequential dependencies and add AI to individual steps. The bottlenecks still survive. For line 4, declarative intent replaces imperative code. 50 years of software engineering trained people to micromanage computers. Every line is an explicit step. AI-augmented developers write the same imperative code with AI suggestions. The output is still a long sequence of explicit instructions. AI-native developers describe what systems should achieve and the constraints around it. AI generates the implementation. The hardest unlearning is the urge to specify how instead of what. Senior developers struggle with this more than juniors. Fault line 5. Prompts are primary artifacts. Code is ephemeral. In augmented organizations, the source repository holds the intellectual property. Prompts are scratch work. In native organizations, prompts and context definitions are the intellectual property. They are versioned, tested, governed, deployed independently from code, treated with rigor previously reserved for source files. Code becomes a regenerated output. When intent changes, regenerate the code. When model improves, regenerate the code. This inverts decades of intellectual property assumptions, and most organizations resist this inversion harder than any other change in the framework. Fault line 6. Humans orchestrates, agents implement. AI-Augmented has human writing code with AI assistance. AI-Native has human defining intent, designing prompt hierarchies, validating outcomes, and resolving strategic trade-offs. Specialized agents handle implementation, testing, integration, and deployment. The work is different, the skill is different, the career path is different. Adding AI-Augmented to a developer's title preserves the old role with marketing applied. Restructuring around context engineers, prompt engineers, AI solution architects, and AI quality engineers redraws this work. Fault line 7. Systems evolve continuously. They are not frozen between releases. Traditional software is frozen until the next release ships. AI-Augmented software ships faster but stays frozen between deployments. AI-native systems evolve through self-healing operations, predictive maintenance, autonomous regeneration of underperforming components, and learning pipelines responding to production usage. The 3 a.m. page rings less often because the system remediated the anomaly 6 minutes after it fired. Deployed and freeze stops being the unit of progress. Fault line 8. Parallel orchestration replaces sequential handoffs. Traditional development is a relay race. Requirements to design, to development, to testing, to deployment. Even sprint-based methodologies maintain sequential dependencies inside the sprint. AI-Augmented preserves the relay race and makes individual legs faster. AI-Native runs as parallel agent execution. UI agent, logic agent, data agent, security agent, testing agent, all working simultaneously against the same context, coordinated through orchestration patterns. The acceleration is nonlinear because the bottlenecks of sequential dependency disappear, not because typing speed increased. Fault line 9. Quality validates outcomes against intent. Traditional quality engineering checks whether code does what code says. Coverage metrics, syntax validation, test phases. AI-Augmented does the same checks slightly faster with AI-generated test cases. The discipline is unchanged. The AI-native quality validates whether the running system delivers the outcome specified in the context prompt. The quality engineer asks a different question, not does this function return the expected value? Instead, does this system produce the business outcome the context committed to? When prompts define success criteria explicitly, quality engineering measures against that criteria. The output is intent fulfillment, not code coverage. Fault line 10. Context compounds across projects. It becomes an organizational asset. Requirements documents die with a project. They sit in a confluence space and decay. Context repositories grow across projects and compound. Each new system inherits domain models, business rules, regulatory constraints, and quality patterns from every previous system. AI-Augmented organizations restart from scratch on every project. AI-native organizations start from the largest, richest context repository they ever had. The compound effect is what makes the productivity gap widen over time. Augmented gains plateau in year 1. Native gains accelerate every year as context accumulates. Fault line 11. Token economics replaces headcount economics. AI-augmented scaling means hiring developers. Costs are fixed, capacity is human, and customization is expensive. AI-native scaling means provisioning tokens. Costs are variable, capacity is elastic. Customization that previously cost $500,000 in developer time cost hundreds in tokens. Innovation funnels open up because testing an idea drops from millions to thousands. CFOs notice this shift before CTOs do because the economic model is part of AI native that makes the strongest business case. Variable cost tied to value delivered changes how the entire company thinks about software investment. And fold line 12. Commitment is binary. Half native is augmented with extra steps. There is no gradient between AI augmented and AI native that delivers native results. Either the lifecycle is rebuilt around AI or it's not. Half measures consume budget and produce the worst of both worlds. AI complexity layered on traditional bottlenecks, token costs without the productivity returns, role confusion without the role clarity. 3 years of half measures cost more than 2 years of discipline transformation. The middle path is the most expensive option on the table. One diagnostic question for you and your team. On which fault line is your organization standing on the AI augmented side of the column? Walk all 12. Count the ones where you are on the wrong side. That count is the diagnosis. Fault line 12 is the answer to what you do with this count. The life cycle is rebuilt or it's not. Half measures cost more than discipline transformation. Across the next 12 episodes, each fold line gets its own deep dive. One principle, one specific contrast, one named industry example, one question you can take into your next staff meeting. The episodes deepen the diagnosis. The rebuild is a single program, not a menu. The book is The AI-Native Software Development Lifecycle. The free framework diagram is at sdlcisdead.com/framework-diagram. The matching LinkedIn article published recently lays out all 12 principles in one read. Next episode, fold line 1, Whole-Lifecycle Rebuild. Why phase substitution caps your AI program at 6% and what the rebuild looks like in the 6 software development lifecycle phases.